Hello everyone. So give me 1 second. So firstly let introduce myself. Let me introduce myself. My name is Said Kibarov. In this small presentation I am going to present you the DC machines. So generally I will go through the questions step by step. Here, by the way, you can see the DC machine. As you can see, I have divided my display to two parts. The bigger one is for the content, and the smaller one is to provide the appearance of myself. I think it's better. So we have 5 questions. I prepared some PDF file in order to answer them and go through them. I will answer step by step. So let me start with the first one. Explain the physical structure of a DC machine with the help of a drawing. By the way, these drawings, it's not my work. I took them from Google, but I did some minor changes. I add the names and arrows, so I worked on them also. From this drawing, basically you can see the DC machine and the parts of the DC machine, which are the stator, field winding, armature core, armature winding, brush. Actually I have 2 brushes, the second one is here. Shaft at the middle and the commutative part. So these ones are just the names. So let's go on. Show the field and armature components and clearly mention if those parts are stationary or rotating. So I have 2 drawings for this part. This is the field and this one is for the armature. From this picture you can observe this is the field magnet. Okay, so the objective of the field system is to create a uniform magnetic field in which the armature rotates. And yes, you can understand that field is the stationary and armature is the rotating part. Okay, let's go on. This is the second question. Define and explain the electromagnetic forces acting in this machine. We have a drawing here. So this is the magnet source and north. This is the coil. These arrows shows the current, force and the magnetic field. So mainly current is coming in from this side and goes outside. This is the direction of the currents, this is the direction of force, and this is the direction of magnetic field. Electromagnetic forces acting in this machine. I want to mention this. We have electric current which is coming in from this side. When electric current which is coming in passes through a coil, this one is the coil, a magnetic field or the magnetic force produces a torque which turns the DC machine. So we have a magnetic force acts perpendicularly. We have a magnetic force which is perpendicular to the B field, and also it is perpendicular to the current. Okay, what else? Also I want to say that when current is going in and current goes out and this coil is rotating, the current is a DC current. It just changed the polarities from plus to minus. I mean, by usage of commutator and brushes we can rotate the coil. Okay, it is done for this part. Let's go to next. And the next one is explain the role of commutator and brushes in DC machine. So you can see that I have a picture drawing of a commutator, this part, and also I have a drawing the brushes. We have two of them, this one and this one. So let's begin with the commutator. Sorry. Basically, commutator have two functions or two purposes. Firstly, the function is to provide a path for a power to enter or to leave a rotor or rotor winding. And the second function for the commutator is to switch the direction of the current flow within the armature winding. So it is asked to mention if the commutator and brushes are stationary or rotational parts. I want to say that commutator is rotational part and brushes are the stationary part. So what about the brushes? Being a stationary part, they connect commutator to outside world. We have them in DC machines to supply power to the rotor. Okay, that's it. So, sorry. Next question. We have to draw and show the equivalent circuit of a DC machine and explain the equations for the induced voltage and for the torque. So, we have a drawing. I did some minor additions. From drawing, we can observe two sides. The left hand side is the armature, the right hand side is the field. Let's start with armature side. In armature side, we have the terminal voltage, we have the armature current, we have the armature resistance, and also we have the armature induced voltage. On the right hand side, field side, we have the field winding, field resistance, field voltage, and of course field current. So I want to say something about the modes. When the terminal voltage is greater than the induced armature voltage, it is a motoring action, and if the armature induced voltage is greater than the terminal voltage VA, then it is the generating action. So I have two equations, armature induced voltage and torque equations. This left equation is for the armature induced voltage, and this right equation is for the torque equation. From the above two equations, we can see that the armature induced voltage EA, this one, is proportional to the speed, this speed, and it is proportional to the armature current IA. What about the second equation? Torque is directly proportional to the square of armature current. You can see from here. And here I have write the variables which used in equations, namely the constant on a machine construction, magnetic flux per pole, angular speed, and the armature current. So I am on the last part of my presentation. In the last part we have to talk about power flow in motoring and generator modes. So I have two drawings here. Let's start with the generator. So this diagram shows the power flow of a DC generator. I think it is the convenient way to see and understand losses from the diagrams like this and this one. So for the DC generator, as input we have the mechanical input power, as output we have the electrical output power. What about losses? Of course we have them. Here are the losses, namely mechanical losses, core losses, copper losses, and stray losses. So now let's come to the power flow diagram of a DC motor this time. So Input and output is just opposite of the upper one. As input we have electrical input power, and as output we have mechanical output power, and losses, which are copper losses, trail losses, mechanical losses, and core losses. Okay, this is the end of my presentation. Thank you for listening. Have a good day. Bye.